Right, let's have a look now at different types of equations. Now in the book, section 4, as you can see, starts off where we've just left off before from trig, with simultaneous and quadratic equations. Now, sometimes we have equations here. A problem consists of two unknown quantities. Two equations are normally needed to solve these quantities. So we can solve them together. That's where the word simultaneous comes from. Now we have two methods. We can use a method called substitution or the method called elimination. Okay? And I'll show you both of these and see how they apply. This is a typical one. Consider the following: 2x plus 3y equals 21, and at the same time 2x minus 1y equals 1. So what do you need to do when the examiner asks you? We need to find values that fit x and y in both equations. Okay, they have to fit both equations. Okay. Now, if we have a look at them, I'll just rewrite them out here for you. 2x, let's put that in more clearly, plus 3y equals 21, and 2x minus y equals 1. Okay. Now, in this particular case, if we are substituting, then what we can do, let's put this down, substitution. We'll show this method. What we're trying to do is rearrange one of these, okay, to give us the term with one letter on one side and the other letter on the other, and then put it back into the other equation. Okay, if that makes sense, hopefully it does. Right, first of all, in the book we can transpose the second equation. If I take this one here, notice that I can do this with it. I can say this is the same as 2x equals 1 plus y. I've taken this down and I brought the minus y on this side over. So now I know that 2x, wherever 2x appears in future in this problem, I can replace it by 1 plus y. Okay, so I have a look now at this equation and I think, look, I've got 2x plus 3y equals 21. But from here, this 2x and this 2x are the same. So what I now do is I can say, right, instead of writing in the 2x, I put this in. 1 plus y, which equals that 2x, that's the same as that, plus another 3y equals 21. So this is why it's called substitution. We've actually simplified equation number 2 to give us a term in 2x. When it appears again in this first equation, I can now get rid of the 2x and put the other term in here, the 1 plus y. So now can you see I've got rid of one of the variables, and now I've got the other variable in by itself. So this is really good. So 1 plus 4y equals 21. So 4y will equal 21 minus 1, because this comes across. So 4y equals 20, dividing out, then I get y equals 5, which is the answer in your book. To get the other answer, I put this back into either of these two. I usually choose the simpler of the two, and I say, right, 2x minus 5, because y is 5, you see, equals 1. Now, I know you can do this by guesswork, but we don't need to bother with that. We can do it more precisely. 1 plus 5. This comes across. Change side, change sign. 2x equals 6, therefore x must equal 3. 6 over 2 is 3. So the final answer is x equals 3. I'll just write it down here. X equals 3, and y we said was equal to 5. Now, if you want to do a little check for your own peace of mind, let's do that. 2, and we put the numbers back in here. 2 times 3 plus 3 times 5, 15, 6 is 21. That's correct. That's good. Okay, 2 times 3 minus 5, 6 minus 5 equals 1. So the little check there, this is good for the examiner as well, okay, because you can check to see whether you've done the correct method and you know that your answer is right. So very good. Move this back down a little bit. Okay, that's a substitution method. That's a good way to use if you don't have too complex a pair of equations. Now let's have a look at this other one. This is elimination. Here we try to get rid of a letter, not by substituting in, by literally adding it out or subtracting it out. So let's have a look at this one. The one in your book, 2x plus 3y equals 21. 3x minus y equals 4. Okay, the idea here is to look at the coefficients in front of the letters. So 2 is in front of x, where 3 is in front of this x, minus 1 is here, and 3 is here. So I look at these and I think, okay, can I make either the y terms the same or the x terms the same? In other words, if I had the same coefficient in front of the x, I could then either add them or subtract them to get rid of them. Well, I notice here that if this number, 3, were in front of this one, then I'd have 3y here and 3y here. That's convenient because then I could either add them or subtract them and they would drop out. So this is what I do. Here's the solution. Step 1, I pick the variable that I want. I'm going to choose y, and I want to make them both into 3y. So I do that by multiplying equation number 2, this one, equation number 2, I'll multiply that by 3. Here we go. Okay, so 3 times 3x is 9x, 3 times y is 3y equals 12. I multiply the whole thing. So this is my new equation. So now I rewrite these equations again. Let's do that. Okay, so I'll do it like this. 2x plus 3y equals 21. That's unchanged as before. This equation 2, we have now changed it by multiplying it all up by 3. This now becomes 9x minus 3y equals 12. Now at this stage I notice that the coefficient in front of the y is the same. So I put brackets around the whole thing. I've now got to decide, do I take this second equation here away or do I add it? Well, mentally, if I make that a minus, this is 2 minus 9, which is minus 7. Here, this would be 3 minus a minus is plus. No good. Okay, they don't cancel out. So I add them. 2 plus 9 is 11x. Now watch this. 3 plus minus is a minus. 3 minus 3y is 0. Here we go. 21 plus 12 is now 33. So x, when I divide throughout by 11, I get x equals 3. If that's the case, what does y equal? Well, let's go back to the simple equation up here. Now 3 times x, which is 3, minus y has to be 4. 9 minus y has to be 4. So therefore y must be 5. 9 minus 5 is 4. Okay, there we go. And you can see that there. And if you have a look at this, you'll find that in fact that would be the correct answer there. Alright, let's just turn this over, have a look in the book. And in fact, those are the answers that we have. X is 3 and y is 4. Let's just confirm that. There we are, x is 3. Here we go. And we've plugged it back in and y is 4. Now, what you can do is use the same technique here and see if you can get the answers. I've put the answers in here for you using the same idea. My hint at this stage, if it was me and I was doing this, I noticed that this is 2x, this is 4x. All I've got to do really is double all this up to make that 4x, and then I can subtract the two, one from the other. Let's have a look at this one here. This is a word problem. Now we haven't done any of these in particular. Mostly the problems are given to you and you just have to go straight into the solution. But with the word problem, you've got to come up with the procedure first. Okay, let's read it first. The sum of two numbers is 20. Their difference is 6. What do you have to do? We have to make two simultaneous equations and solve them for the numbers. Okay? Right, in this case, the examiner is testing a deeper skill, whether you can actually derive from written information the actual formulae. So what I would do is this. I would say let the numbers, and you can write this down, it's good technique for the examiner at least, be A and B. Okay, or X and Y if you want to be. It doesn't really matter as long as you stipulate what you're doing. Now let's have a look at the procedure. The sum of two numbers. So one equation is this. The difference is 6. So the other equation is that. Okay, so now we can solve this out. This is quite an easy one. I put a line under there, and watch this. Because the number in front of A is the same, they're both 1. A minus A is nothing, but here's where we win. This is where this method is really good. B minus a minus is a plus. B plus B is 2B equals 20 minus 6, 14. Therefore, B must be 7. So A minus 7 has to be 6. So A must be 6 plus 7. I take that to the other side, so 13. And as you see in your book, the answers that I've given there are 7 and 13. So in this space, you can just write this little solution in, and this is a good example of a word problem. And this method of elimination is to be preferred. Elimination you can use every time. All right. Substitution you may not be able to use every time because it's a little bit more complicated. So you've got to be more careful. You're more likely to make a mistake with substitution than elimination. This is the preferred method. Okay, well done if you followed that. Now on the other page we're coming into another type of equation, not simultaneous but quadratic. Alright, now let's just have a look and read a little bit of this. There's a basic formula here. General quadratic equation is known as ax squared plus bx plus c, which equals 0. Now again, there are a number of ways of dealing with this. Two common methods exist. You can factorize and complete the square. Okay, but look at this next point. In the majority of real-life situations, the use of the quadratic formula is to be preferred. The reason being is that factorization doesn't always apply here. Sometimes they're more complicated. Completing the square does work, but it can be complicated as well. I kind of like the easy way out, where the quadratic formula here, once I know this one, I can apply it to every one of these and it will work. The other bonus that you have in using the quadratic is that it can show you a way of leading into complex numbers, and we'll have a look at that in a minute as well. Okay, now here's the first example. It says find the roots of 3x squared minus 9x plus 5. In other words, when it said find the roots, the word roots there simply means the values of x. Normally there'll be 2. Okay, so this is what we do. Using the formula, okay, let's just go back to this formula. To find x, then we need to know what a, b and c are, what the coefficients are, put them in, and we can solve this. So this is your formula. Often you're given that in an exam, but you'll be using that a good deal. Okay, here we go. So a is that term, b is that term, and c is that term, but we've got to be careful. We've got to take the sign with it. So a equals 3. What would you write down for b? Well, if you say minus 9, you're correct, because the minus sign affects the 9. And for c, it's going to be 5. Notice if we just have 5, we don't put plus 5, it's redundant, but we do need to put the minus in. So now we substitute in the formula. So here we go. Now at this stage, your calculator doesn't really help you very much. You've got to do this. This is a lot of head stuff that you've got to do, but you'll be used to that. Here we go. X equals now minus b, be very careful, plus or minus the square root of b squared, okay, minus 4 times a times c. I tend to put them in brackets there, all divided by 2a. Right, and just check that. It should check with the formulation that was in your book. This now gives you 9 plus or minus. All this works out, you can put this in. Now minus 9 squared is just 81. So 81 minus 120. Here 4 3s are 12, 60. Okay, so this is going to be 60 from 81. This will give you 21. All over 2 3s are 6. And you can put this into your calculator. What it means is that you have two answers. Okay, so I'll work through this just to make sure you know what we're doing. Okay, so the square root of 21 is going to be that 4.58. Let's just use 2 decimal places. So this becomes 9 plus or minus 4.58 all over 6. Now from here you get two answers. You can add 9 to this and divide by 6. So you'll get 2.26. So one answer is 2.26. So that will equal, divided by 6, well, we get a decimal, okay, 0.74. There we go. This one was divided by 6, so that's correct. This one now is divided by 6, so now that's correct. You can just add that one to the video. Yep, lovely. Okay, let's reassess this one. Right, on the last page, I'll do this next problem here. This is quite an interesting one. It said find the roots, and I'll show you why it's interesting. X squared plus 6x plus 25 equals 0. Now again, we go through the procedure. A, B, C. A here is 1, because there's only the 1 there. Okay, if there's no number, then it's just unity. B equals 6, C equals 25. Now we put them in. X equals minus B plus or minus the square root of B squared minus 4 times A times C all over 2A. So I'll put the numbers in like that so you can check them. You see I've substituted them in carefully. But now watch what happens. This is quite amazing. Minus 6 plus or minus. Now 6 squared we know in our heads is 36. 4 times 1 is 4. 4 25s are 100. All over 2. And all of a sudden we have a very strange phenomenon. 36 minus 100 is negative 64. Now, some of you might realize that, let's have a look, is there a square root? Can we do that? Well, watch what happens if you try and do it on your calculator. The square root of negative 64, close brackets, math error. Oops, because it doesn't exist. Okay, you can't take the square root of a negative number, it doesn't exist. So what we do is this, we box clever and we rearrange it. Minus 6 plus or minus. Now this can be broken down into the square root of minus 1 times 64 over 2. Further simplified, minus 6 plus 1, minus 1 multiplied by, the square root of that is 8. What do we do with this little fellow? Well, minus 1 here, that's right. Now the square root of minus 1 is now typically, in some books it's given as the letter I, but if you're using electricity or electronics, that's often confused with current. So books have changed to show I being replaced by J. So what we have now is this, minus 6 plus or minus 8J over 2. And as soon as we bring this term in, we're dealing with another branch of maths, which you'll need to know, called complex numbers. This finally works out to be quite nice, as x equals, now 2 into that is negative 3 plus or minus 4j. And in your book, that's what we have. Okay, there's your complex numbers, and the two answers there, minus 3 plus that, minus 3 minus that. Okay, at this level we don't need to go any further because that's a separate branch of maths that you will be dealing with later on. In your book, there's another one I've given, a couple more at the bottom with the answers there. So on your own, you can find the roots of these two numbers, or these two equations, and see how they work out for you.